Okay, this video is for, well, me first of all, and then anybody else who has this problem. Syncrowave 350LX. It's one of the flat fronts. I was having trouble, really, I think since I got the machine. I got it secondhand, and it never felt like the high frequency worked well. But it worked good enough, which is the frustrating part, I guess. So I was doing a big aluminum project, and I've done a lot of aluminum with this machine, but it just never felt like the arc was stable as it should have been. But I fought through it because everything here is expensive, complicated, and can kill you if you're not careful with it. So finally it died. I was doing an aluminum project. High freak got weaker and weaker, and then just, that was it. It would still work, but you had to get within like a 32nd of an inch. You're almost scratch starting it to get it to go. So the points were still firing, but on WeldWeb, there was a gentleman there that was talking about if they're firing, but it's not like, if it looks like a fluorescent light starter, if you have experience with those, versus a really wild, with the whole face involved spark. If it's not the whole face involved, then it's probably the C3 capacitor. And to give you an idea of how this, what goes on here, this whole system here, first of all, is on the 115 volt, if you will, system. The generator, or the welder, does not have a neutral line. It has, as you can see here, a hot, a ground. That's it. So the welder makes its own 115 via resistors and capacitors. So this circuit here is for the front outlet. This circuit here is for the 3600 volt high freak transformer. So if you measure here on one of the input lead, the primary side here goes first. Its power comes into the capacitors, goes through the big resistor, back through the capacitors, and then it goes into the coil. This leg here is just a ground leg. This leg here is where you measure open circuit, or when the welder's just on, but you're not doing any welding, about 40 volts. When you trigger the high frequency, it should be around 150, obviously 154, 157, but it should be significantly more. It should be a lot more. You'll see about 115 on the input to the resistor. Over here, you'll see a bit more after the resistor or the capacitors do their thing. So based on the fact that I had voltage, I was seeing an increase of voltage. I'm sure the primary side was charged. Secondary side, I don't know how much it was making because I have nothing that would read it, but I was getting arcing through the gaps, air gap. You can measure it and it'll tell you roughly what it is for voltage, but it was definitely more than 115 volts. So what happens is with this capacitor is when the spark jumps the gap, the capacitor then starts to absorb energy. It stops the spark from jumping, it builds enough current, and then it discharges. So the 3600 volts is enough to bridge this gap, but this capacitor is like a super fast supercharger to that really wakes the system up. And then you can see here these red wires here. One goes to each side of the bottom of the high freak spark gaps. One leg of the transformers right here. You can see that goes, I'm sorry, one leg of the capacitors right here. And then the other leg of the capacitor goes through this resistor here, which controls the high frequency intensity. And then that goes to the high freak inductor coil, which is right behind this panel. It's a big aluminum coil. Actually, you can see it right there. That's the aluminum high freak inductor. There's a little coil inside of that is excited by, again, this wire off of, that comes from the capacitor, goes through the resistor. That's one side of that coil for the high freak. And then the other side comes directly off the high freak spark gaps. So if you're having high frequency, but it's super weak or it's getting weak, it's this C3 capacitor here is likely the problem. I will say the parts for these are getting super expensive. This transformers is $250 right now. These little guys here are about $150. This one, this capacitor isn't even available. So here's the original one here. You might have one that looks like this. This is the old C3. They've been updated. So this is one off one of the newer machines there, one of the black plastic box style. And one thing I will say that I did that I was really, it took me a little bit of time, but you see there's screws here. All this stuff was riveted originally. I took everything, busted all the rivets. You gotta be careful. Put a guard plate on the other side, or watch what you're doing with or use a drill depth stop or something, because there's expensive stuff on the other side. But I poked all the rivets out and then put riv nuts in, and then I can use screws to get all the stuff out, which will make any future issues better. Also, I noticed the rivets I got loose. This thing really flopped around a lot, but now it hardly moves because I can tighten up the plate. So that's the rundown of the high frequency on a Miller Syncrowave. Hope this helps you. Find me if you have any more questions. I can point you in the right direction. Take care.